Let's look at some applications of a diode. We are going to see how a diode works as a half-wave rectifier. So we need to first know what's the meaning of a rectifier. Rectifier is a device which converts AC current or AC supply to DC supply. Now we have got a circuit diagram in which we have got an AC supply which is connected to a diode and a resistor. So in AC we can see there are positive halves and negative halves. So we are going to start from the positive half. So we can see that the power supply has the top as positive and bottom as negative. So the positive of the source is connected to the P type of the diode. That means it is forward bias. So the current will pass through the circuit and we can see that we get an output voltage same like the input voltage. Now when AC reverses its polarity, that means when we go to the negative half, so the top becomes negative and the bottom becomes positive. This time the negative of the source or the power supply is connected to the P type or P side of the diode, which means it is reverse biased and therefore no current will be allowed. So we can see that the voltage, output voltage is 0. That's why this is called as a half-wave rectifier circuit, because it converts only positive half whereas cuts off the negative half. Let's see how to analyze a full wave rectifier. So we are using here two diodes to make a circuit for a full wave rectifier. Let's quickly recall that rectifier is a device which converts AC to DC. So we can see that we are using an AC power source in this circuit diagram. Let's look at the positive input cycle of the power source. So the top of the source is positive and the bottom is negative. Now we have to check which diode is forward biased and which one is reverse biased. So D1 is connected to the positive of the source. The P side of D1 is connected to the positive of the source, therefore it is forward bias. The P side of D2 is connected to the negative of the source, so it is reverse biased. And we know that in forward bias it will allow the current and in the reverse bias it will not allow the current. So the current flows from the source and enters into the branch where there is resistor, but it will not flow to the branch where there is diode D2. So this D2 is reverse bias, so it does not allow any current through it. So we have got the current in the resistor branch and it completes the circuit and we get a positive output, voltage output across the resistor. Now what happens when it goes to the negative cycle? The top of the source becomes negative and the bottom of the source becomes positive. And again we have to identify which diode is forward and which one is reverse. So we repeat the process and we find that D1 has its P side connected to the negative of the source, so it is reverse bias. And D2 has its the P type of the D2 is connected to the positive of the source, so it is forward bias. So this time D2 is going to allow the current and D1 is going to block the current. So let's see how the current flows. The current flows from the source. It starts from the source, goes through D2. Then it has two options. Either it can go left or right, or it can split. But it sees on the left side there is a D1 diode which is reverse biased, so it will not allow the current. But on the right side there is a resistor which allows the current to cross it, to flow through it, and therefore the current will go through the resistor and the circuit is complete, and we can see that we get a positive output again across the resistor. So what has happened? This full wave rectifier has converted both the halves into DC. So positive cycle has come out as a positive output, whereas the negative half has also been converted into positive half. The reason how do we know that both of them become positive is because if you check the direction of current through the resistor, it is same direction for both the cycle. That means the voltage is in the same direction, and therefore both the voltage halves becomes positive, and therefore it is called as a full wave rectifier.